Okay, welcome everybody to our tutorial for this week. We are now beginning with week 8 of the semester, and for this week we are looking at exercise 1.2. I will be discussing 3 questions, number 21, 25 and 29 of exercise 1.2. So the question asks us to find the limits. Let's have a look. Question 21, it says find the limit of y plus 6 upon y squared minus 36 as y approaches 6 from the right. Okay, so that's our question. So first thing we would like to do here is we would like to factorize our denominator. So that gives us the limit of y plus 6 divided by y plus 6 into y minus 6 as y approaches 6 from the right. Then from there we can see that we can cancel out y plus 6 and y plus 6. So this leaves us with the limit of 1 upon y minus 6 as y approaches 6 from the right. Okay, so if we look at our problem here, this expression here is a hyperbolic function. So if we make a plot, so if you substitute 6 here, you'll get 6 minus 6, which is 0. 1 upon 0 is undefined, so therefore that tells us that at 6 we have a vertical asymptote. So if we make a sketch of this hyperbolic function, it would have that shape. So now the only thing we need to do is we see our values approaching 6 from the right. So if as the values of y approach 6 from the right, see that our function approaches positive infinity. So therefore we can conclude that the limit of 1 upon y minus 6 as y approaches 6 from the right is positive infinity. Okay. Alright, so the next problem is number 25. So the question says find the limit of 3 minus x upon x squared minus 2x minus 8 as x approaches 4 from the left. Okay, so first of all, let's factorize our denominator. So to factorize this, we find two factors of negative 8 that add to give negative 2. So our two factors are negative 4 and positive 2. So when we factorize that, problem becomes the limit of 3 minus x upon x minus 4 x plus 2 as x approaches 4 from the left. Okay, so there are a few ways that you can solve this. One of the ways that you can solve this is by considering this as a bottom heavy rational function, which you covered in year 13 mathematics. So if you consider this as a bottom heavy rational function, our denominators here, they will determine where your vertical asymptotes will exist. So therefore if you solve your denominators, if you set them equal to 0, so that means if you have x minus 4 equal to 0 and x plus 2 equal to 0, so if you solve this, this will be equal to x equals to 4 and x equals to negative 2. These two are our vertical asymptotes. So if you make a sketch of this, so you have your x's here So at -2 you have your vertical asymptote there, and at 4 you also have your vertical asymptote there. And if you make a sketch of your graph would have that shape. It would have that shape, and then it would have that shape. Okay, so that graph helps us to better visualize our problem. So we want to find the limit as x approaches 4 from the left. So since 4 is here, we have to see as our x values approach 4 from the left, we can see that our function approaches positive infinity. So therefore we can conclude that our limit is positive infinity. Okay, so our third problem is problem number 29. Again, we want to find the limit of x minus 9 upon root of x minus 3 as x approaches 9. Okay, there are two ways that you can solve this problem. Okay, the first one, you can factorize your numerator. Treat them as factorize them using a difference of squares. So in other words, my problem can become x minus 9. If I factorize that in terms of square root x and -3, x is same as square root x squared, 9 is same as 3 squared. So if you factorize that using difference of squares, our numerator is factorized into square root x minus 3 square root x plus 3 upon square root x minus 3. Okay, from here it's clear that we can cancel out. Square root of x minus 3 cancels out with square root of x minus 3. So our problem becomes the limit of the square root of x plus 3 as x approaches 9. Okay, so our problem becomes much easier to solve now. So we just do a direct substitution in place of x. We put 9. So substitute in 9. So this gives us the square root of 9 plus 3. Square root of 9 is 3 plus 3, which gives us 6. So that's one way you can solve this problem. Another way you can solve this problem is, if you consider your denominator has square root x. What we can do is we can rationalize our denominator. So let's do that. So we have the limit as of x minus 9 upon square root x minus 3 as x approaches 9. So let me rationalize my denominator. So I will multiply by the conjugate of it. So multiply by square root of x plus 3 upon square root of x plus 3. So I'll multiply both my numerator and my denominator with the conjugate of the denominator. So from here we can directly multiply our numerators together and multiply our denominators together. Okay, so what does this give us? So this becomes the limit, so x approaches 9. So you'll have x minus 9 multiplied with square root of x plus 3. Okay, so just expand this. So square root of x times square root of x will become x. Root x times 3 will become 3 root x. Negative 3 times root x will become minus 3 root x. Minus 3 times positive 3 will become minus 9. So simplifying this gives us the limit x minus 9 square root of x plus 3 upon, so if you simplify this, 3 square root x minus 3 square root x, that will cancel out. So your denominator you're left with x minus 9 as x approaches 9. So from here it's clear to see that we can cancel out. X minus 9 will cancel out with x minus 9. So our problem becomes the limit square root of x plus 3 as x approaches 9. Again, like our first method, now we can just directly substitute in place of x. Let's put 9. So this becomes the square root of 9 plus 3. Square root of 9 is 3. So plus 3 gives you 6. There you go.